Welcome back, AP. 5.6 Hess's Law is probably one of my favorite laws. It's super easy and kind of cool. It's like a little puzzle into it. So the learning objective is 3 point C, represent a chemical and physical process in a series of steps. So if you have a series of elementary steps to make a mechanism, how do you get the overall delta H? So Hess's Law has two principles. So first, number one, if the reaction is reversed, so as in you flip the balanced equation, okay? So if you had A made B, and then now you want to flip it and have B makes A, what happens to the delta H value when you flip it, okay? The delta H value stays constant in magnitude as in size. So that means the number is constant. However, it's a reverse in sign. So if it was positive 100, let me scroll up some. If it was a positive 100 kilojoules, so then now when you flip it, it'll be negative 100 kilojoules, okay? So when you flip the equation, change of a sign. Number two, when you have two or more elementary steps are added to get the overall mechanism, what do you do to the delta H's? Well, you add them up also. So an example right here before we do an actual practice problem. If I have two elementary steps, and this is my mechanism, and I want these two elementary steps to come together to form this mechanism, if you notice you have CH4 gas, I have that where I want them. I have 2O2 gas, I have that where I want it. And I have CO2 gas right here also. And then I have two liquid waters. Well, in the first equation, I produced two water gas, two water vapor. Well, I don't want vapor. So that must mean that water vapor, this is an intermediate, which means if it's produced in one step, it gets consumed in another step. So the water as a vapor is an intermediate, is canceled. So I have everything where I need it. I didn't need to flip it. So my overall delta H of reaction, I just add up the two values and I get the overall delta H. Now, whether they want it in kilojoules or kilojoules per mole, either one is fine. Okay, let's try one. Okay, so Hess's law and the rules, okay, as you saw from the learning objective, okay, and we're going to use it to do this practice problem as you see right here. If a reaction is carried out in a series of elementary steps, doesn't matter how many steps to get to the final answer, the delta H for the reaction, we just add it all up. But what happens if you have to mess with the balance equations? So if an equation is reversed, if it's flipped, then you change the sign of delta H. If the equation is multiplied, as in the coefficients, okay, well, then you multiply the delta H. So if you have to take the coefficients and multiply them or divide, as in like change them to like 1/2, then you do the same thing, or divide by 1/2, okay? And then in the end, as we said, add it all up. Okay, sounds pretty easy because it is very easy. If by chance you would like to listen to Fairbra, go to this video on YouTube, type it in 6.6 to 6.9, fast forward to about 44 minutes, and you'll see him explain it as just like I'm going to do. AP type of question. Show how equation 1, 2, and 3 can be manipulated and combined in a certain way so that way it equals equation 4. So if I want to take these three equations and get this final delta H value, how can I manipulate them and combine them to get that overall? Okay. As you are manipulating the equation, manipulate the delta H's and calculate delta H reaction. Okay. So over here, I like to do my work on this side, and then I keep track of what happens to my delta H values over here. And it says the delta H's are kilojoules per mole. Well, first, number one, I like to figure out, do I need to flip? do I need to flip any of the equations? So I like to see where I have all the chemicals. So if you notice right here, I got carbon as a solid, and I have them where I want them. So I know I'm not going to flip this one. But I have 2 carbons, and I don't see carbon anywhere else. So I'm going to tell AP, I'm going to multiply by 2. So that means this gets multiplied by 2, and multiplied by 2, and multiplied by 2. So over here, when I show my work again, I don't worry about states of matters here because I already have my balanced equation right there, and I already have all the states of matters right here. And luckily enough, they're all gases except that carbon. So when you're showing your work, doesn't matter about the states of matters right here because you already have it over here. So I'm going to take this 2 times negative 394. So let's bust out those calculators, and as always, check Rodriguez's fingers on plugging it in. And we're going to maintain those sig figs. So right here, I'm going to get negative 788. Okay, and I already have my units up here, so I don't have to keep writing them right here. So check, that one's done. Let's check the H2. I have my H2 on the reactant side, just like I have it right here, but I don't want 2 of them, and I don't see H2 anywhere else. So I'm going to tell AP, I'm going to divide by 2. So that means this 2 is gone. I'm going to have 1/2, and then that 2 is going to be gone. So I'm going to have H2, I'm going to have 1/2 oxygen, and then I'm going to have water. Okay, so same thing right here, I'm going to divide by 2. So negative 484 divided by 2, and I'm going to get negative 242 for this one. Okay, so far I haven't had to flip anything. But now I look at this first equation. This first equation has C2H5 as a product, but I have it as a reactant here. So I know this guy's going to get flipped. So I'm going to cross this out because I don't want to pay attention to it. And I'll figure out in just a second if I want to manipulate coefficients once I flip it. So C2H2 and then 5/2 O2. Okay? So I have this guy where I want him. Now he's on the product side. And let's start going through to see if anything cancels out. So automatically, I need to have the following equation. So I need 2 C's as a solid. I need H2 as a gas. And I need this 1 C2H2 and then as a gas. Okay? So I have it right here. 2C2. I have it right there. I have my 1H2 on my reactant side also. And I have on my product side my C2H2. So I have everything I want it. That means everything else is either an intermediate or a catalyst. So let's check it out. So I have 2 CO2s. So automatically this guy, that's a catalyst. Okay. I have water. And because water was gases in both of them, I know also that's a catalyst. Okay. If one is a gas and one is a liquid, they don't cancel out. Okay. And then let's look at these waters. Okay. Or I'm sorry, let's look at these oxygen. 5/2 O2, and then I have 2 O2, and then I have a half. Well, what if I took this 2 as a whole number? What is it as a fraction? Well, as a fraction, isn't it 4/2? I know that looks weird because, you know Rodriguez has always told you do not put even numbers over 2. That looks weird. But isn't the number 2 out of a fraction, and a fraction 4/2? Well, instead, if I take that 2 and write it as a fraction, what's 4/2 plus a half? Well, it equals 5/2. And that means oxygen is gone, which means oxygen was an intermediate. Okay? You never know what AP could ask you. So because this equation right here was flipped, well, then I need to flip the sign. So now this is going to become positive 1256. All right. And now we're just going to add them up. So the delta H degree sign, and we'll talk about that little degree sign in the next video. Okay. We're just going to add them all up. So 1256 plus a negative 788 plus a negative 242. And if we did this right, we're going to get that answer, which we did, which is 226. So 226 in kilojoules per mole. Okay? And because the delta H is positive, means it's an endothermic reaction. Okay? Very simple law, very fun law. I like it because I like to figure out how they get flipped and manipulated and how they get combined. So number one, do I need to flip anything? And then number two, do I need to change any coefficients? Okay, so that's pretty much the two questions you need to ask yourself. Okay, all right, and one more video to go.